All right, so we're rolling, guys. Today we're going to talk about quadratic inequalities. All right, so you guys have had some work with inequalities in the past, but never with quadratics before. I don't know if you remember this back in Algebra 1 or not, but you guys dealt with linear inequalities. And by inequality, all we mean is not equal, so greater than or less than, that sort of thing. So, I don't know if you guys remember this or not, but it was a lot of graphing that you were doing. Yeah. And so I'm going to present you guys with a problem you probably had before, where you had to graph to find a solution. Kind of like we were doing yesterday, but this time, like I said, it's with inequalities. So you might have seen something kind of like this. Y greater than x plus 5 and y less than or equal to negative 2x plus 8. And both of those essentially are lines. You want to think of them as y equals x plus 5 and y equals negative 2x plus 8. So you're going to graph those couple of lines on the coordinate plane, and this is those ones where you had to then shade in a certain portion of the graph to show that all the ordered pairs that are in this little region, those are all the ones that are going to work for everything. Okay, so let's quickly get the two lines on there, and then we'll talk a little bit about the shading and all of that stuff, what that means. So, and I think once we're back on track with what all of this is, then when we jump into the quadratic stuff that we're going to be doing, it'll be that much easier for you. All right, so the first equation has a slope of 1. It has a y-intercept of 5, so I'm just going to put some tick marks on here so I can count up and down. Same thing for x. All right, I'm just assuming each one of these is 1, okay? So x plus 5. So slope of 1, y-intercept of 5. So 1, 2, 3, 4, 5. And then a slope of 1 is going to make it look something kind of like this. That's the first one. That's this one. All right, and then the second one, negative 2x plus 8. So that would have a slope of negative 2 and goes up to 8. So it's going to come down and do something like this. Okay, not terribly precise there, but as long as you get the idea, that's the important thing. Okay, those would be roughly where those two lines would be. Okay, so now we got both of them on there. Okay, so you guys remember also when you were doing this, depending on what kind of inequality symbol that you had to either make it a dotted line or a solid line. And that what that meant was if it was a dotted line, it meant all the ordered pairs that are right on the line aren't technically part of the solution set. But if it was a solid line, then all the ordered pairs that were right on the line were. Okay? So this first one, y greater than x plus 5, it's not greater than or equal to, so we're not including the line on that one. So that line, which was this one right here, we're actually going to make dotted. So I'm going to just come on here and darken it in a little bit so that it looks dotted. Sorry if you're using pen. Okay, and then the other one would have been a solid line because that's a less than or equal to type. So that one we're going to include. So I'm just going to make that one a little bit darker just so it's a little bit more obvious. Okay.
The one that's going up,
Yeah.
is that supposed to intersect at x equals 5?
It is. Yeah.
It looks like it's just it's at x plus.
Oh, I don't know. Well, the y-intercept should be 5. The x-intercept may not be 5. Well, actually, it should be 5 too. Anyway, like I said, they're not terribly precise. I just wanted to get them on there so you can kind of just see how this shading stuff works. So it's not a big deal if it's not hitting exactly where it's supposed to go for right now. So, okay. So that first one, y greater than x plus 5. If it's greater than, you shade above. If it's less than, you shade below, right? So this one, we're going to shade above that line to indicate that all the little points that are up here all make that inequality true. And then the other line, it's y less than or equal to negative 2x plus 8. So for that one, we have to shade everything below that line. And so that's over here. Now you guys see what's happening here? There's an overlap, right, of those two shadings. Okay, so if you want to go in and actually make that a little bit darker even, just to kind of emphasize. Okay, so all the little ordered pairs that are in that dark section there. So if I took, like, let's say, I don't know, negative 10, 1, okay, which would be a point like out over here somewhere. Those numbers, if I plugged them into each of those, would make both of those inequalities true. Okay, that's what you were doing when in Algebra 1 when you were doing all this shading business. That's why you were doing that. Because there isn't just one right answer this time. Okay, if there were an equal sign on these things, we could pinpoint those specific little points where it makes it true. That's what you were doing yesterday. You were finding intersection points where at those specific points, those are the only places where it makes it true. But anytime you have an inequality, then there's a whole bunch of numbers that can make it true. Okay, a little bit, except it's a shot in the dark, but we know that they're all here. Okay, so you can't get just one answer, but you can't write down all the answers either because there's an infinite number of them, right? You could keep getting more and more and more and more of these things. You'd never stop writing points down. So you can't do it that way. So the way that we answer these questions is we draw a graph. It's the best we can do. Okay, there's a ton of them, but they're just all in here. And so you draw a graph, and the graph is your answer to the question then. The way that you shade them is if the inequality symbol is greater than, it goes above. If it's less than, it goes below. Okay.
Well, what about the line that's going like this? Like, how do you tell? There's really no above or...
There is. This is above. This is below. This one here? This is above. This is below.
All right.
Okay. Okay. So vertical lines are a little different. But with what we're doing today, since we're going to transition to quadratics here in just a second, we don't need to worry about that. But I can show you that later because we're not going to be doing lines today.
What feels like equal to or like greater than or greater, just like the bottom equation. How do you, what's the equal identifier?
Solid line.
Oh.
The or equal to makes it solid. Without it makes it dotted. Okay? We're going to continue to follow these same rules, but just with quadratics instead. Okay? And we don't even have to graph the quadratics by hand. We're going to have the calculator do that part for us. So all you guys are going to be doing is looking at your calculator, taking the quadratics, putting them on a little sketch, and then shading them in the right way, and making them dotted or solid if they need to be. Okay? It's the same basic process. It's just a different looking equation. Okay? They're parabolas instead of lines. Not a big deal. Okay? So let's try one of those then. Okay? So let's say we've got y less than x squared plus 2 and y greater than or equal to x squared plus x minus 5. Okay, so the inequality symbols just tell us how to shade, right? So in your calculator, you're still going to just type in, so like in your y1, you'll just have x squared plus 2, and in your y2, you'll have x squared plus x minus 5. So go ahead and take those two quadratics, type them in your y equals on your calculator real quick, and we're going to take a look at them. What? Did you have a question? Oh, okay. Oh, that's good. Yeah. I don't have another one anymore. Yeah, are you going to have one? All right. Go ahead. You can go upstairs. That's fine. All right. And if you guys want to make yours look like mine, if you do that whole Zoom standard thing, then it should look like this. Okay? So these are the two quadratics in question for this one. Okay? And by looking at them, you should be able to identify which is which. Okay? Also, if you were paying attention when the calculator actually drew them, the first one that it draws is the first one you typed in, and the second one it draws was the second one you typed in. Okay? Or if you're, have one of those fancy calculators that does it in color, then it actually even color matches it for you too with the equation. So that's kind of nice. In any event, what we need to do though is we need to actually produce our own graph on our paper because, like I said, the solutions to these things are the graphs. So we need to be able to see it, like on your homework assignment or whatever. So let's just sketch what we see on our notes real quick. Okay. So it looks something sort of like that. And for these, I'm not even going to be all that concerned about like labeling the scales and that sort of thing. I'll go easy on you with that, okay? But that's more or less what we saw. Now, do the best you can so that it doesn't just look like a bunch of chicken scratch, though. Okay? I know some people struggle a little bit more. I didn't look at you, but you looked at me, man. Okay, there are some people that struggle more than others with drawing graphs that look like something versus not. So do the best you can to be as accurate as you can. Okay? All right, so let's talk about the shading first of all. Actually, you know what? Before we even do the shading, let's talk about what should be dotted and what should be solid for this one. Okay? So this first parabola, y less than x squared plus 2, that should be a dotted parabola this time, right? So which of the two parabolas is the dotted parabola? Top one. Okay. So go ahead and adjust that real quick. That's got to be dotted. So none of the points that are actually on that parabola are part of the solution then. Because we're only taking points that are less than that parabola, not less than or equal to that parabola.
So less than the underneath that?
Yes. Yep. Okay, and then the other parabola should stay solid, right? Because we are keeping the points that are on that parabola. Okay. All right, so the first one, it's y less than x squared plus 2. So that dotted parabola, we need to shade underneath that parabola. So what that's going to be is actually all of, it's pretty much the whole screen except for what's inside the parabola there. So kind of like that. Yep. I'll show you how to do that in a minute. Yes?
Do we have to shade the whole screen in, or if we know what's going to be the answer, can we just shade that?
Yep. Yep, you can. All right, so it's underneath the dotted parabola, but look at the other inequality. It's y greater than or equal to x squared plus x minus 5. So it's above the other parabola, okay? So this bigger parabola, we're going to shade everything above it. That's not the part that tells us how to shade it. That minus 5 just means it hits down here at minus 5. That's the y-intercept. It's this that tells us. If it's a less than parabola, we're going below the parabola. If it's a greater than, we go above it. Okay? So everybody catch where the overlap was that time? All right, it's this little chunk here in the middle between the parabolas. Nope, that's not a technical term. Please don't use it again. Okay. Piece? Yeah. We're getting better. That's better. Maybe. All right, so that would be your solution then. So every ordered pair that sits in between those parabolas there is part of the solution. Not the ones that are on the top parabola, but yes, the ones that are on the bottom one. Okay? So I'm going to have you guys do another one of these on your own. Okay? Sketch it. Shade it appropriately. Like was mentioned, I don't know if you guys heard that, but there's a question about if I know where the overlap is going to be, can I just shade that in and not worry about the rest of it? Yes, you can do that. Okay. So on the next one, if you, looking at the inequality symbols, can tell where that solution is going to be, just go ahead and shade that part of it then. Okay. So let's give it a try. We're going to be working with y less than negative x squared plus 3 and y greater than or equal to x squared plus 2x minus 3. Okay. Go for it. Not necessarily. I'm just doing that to keep you paying attention. Well, partly. Yeah. The dotted, if it has the or equal to part on the bottom, that's solid. Otherwise, it's dotted.
I'm gonna shade it. Me too.
What?
If it's turned upside down, would it be less than? Would it be inside the?
It's inside the parabola then. Just think below and above. So if it opens down, below it is kind of in the interior of it, and outside would be above it. Yep. I'm waiting for people to finish. Did you write it on there?
Oh my God.
Practice sketching it. You might need
Are we
to.
gonna sketch it? Okay.
All right, guys. Let me show you what I got here. So my calculator produced a graph that looked something like that. Okay. So now, a couple of things that you need to do beyond what the calculator is going to do for you. You need to know which one of these is dotted and which one is solid. And it's not always going to be one is one and the other is the other. It could be both are solid, both are dotted. It just depends. But on this particular one, it should be the parabola that's opening down is dotted. Okay? And then you need to figure out how to shade it. Well, the parabola opening up, you're shading above. So you're in the interior of that parabola. And the one opening down, you're shading below that. So you're in the interior of that one too. So it's this little weird-looking doohickey here in the middle. Doohickey's not a technical term either, but that little thing in the middle there, that's what you're going to shade in. That's where the overlap should be happening then. Yep.
How do you tell which parabola that you got? I'm not sure how to.
Okay.
One that doesn't have the equal.
By looking at the equations of these things,
Also, if they were both like y greater than or equal to.
yeah, if this had been or equal to, then this thing still would have been solid instead of dotted.
All right.
So it's just you're looking for that, and that tells you which way.
So when it has it, it's dotted.
When it
has it, it's not dotted.
correct. So the or
Missing half of which are
yeah,
dotted.
think of dotted as you're missing something.
Yeah.
You're missing something.
That's what
All right. Yep. Alex.
I'm ready to go.
Okay. This one is the dotted parabola, right? And it is less than that. So if I were to have shaded everything for that one, I would have shaded all of that. Okay? So everything underneath that parabola. This one is a greater than for that one. So I would have shaded everything above that parabola, which would have been all of that. So where those two shadings overlap is that little piece in the middle there then. Okay? That's where you shaded both. That's how you know where the overlap. Right. Okay, now, believe it or not, and I don't know if you guys are interested in this or not, but maybe you are. I had people in other classes that are. The shading, the calculator will do for you.
Yeah, what?
Not even joking. Yeah, it'll do for you.
Why didn't you just tell us that?
Well, because I think most people think it's easier to just look at it and shade it rather than try to do it this way.
It is a little bit chemical math.
But no, it could be different for everybody. I don't know. Anyway, it's all right here, okay? So when you do these, when you type these in, nobody ever thinks to do this, but you can actually, with your little arrow buttons, you can move over to where this little slash is next to the Y1, Y2, etc.
Yes, you can.
That's telling you what kind of curve you're going to make. So right now it's saying make it a nice solid curve, okay? If you hit enter, you can toggle through some different things it'll do. If you want to make it like a big thick line, you could make it that way too. This one right here, okay, notice how it's taken that same little line slash, but now it's shaded above it. You guys see that? So the line was going like this, but it's shading above that line. So now it's going to take whatever you've typed in and shade above. If you hit enter one more time, that's the shade below. Looks like that. Okay? And you can keep going through some other stuff if that's, don't worry about that one. You can do a dotted line. If you want to do just a dotted line. You can't dot it and shade it though. Okay? But, so the top one needed to be shaded below, correct? So it would be that. The bottom one needed to be shaded above. Let me get back to it. There we go. So hit graph. Here it goes.
Let's see if I did it right.
Okay. And see how one of them shades with vertical lines and the other one shades with horizontal lines? So when they overlap, it's really easy to see where it is. Okay? It's something that's helpful. Sarah, question? I did those. Yeah. When it's the triangle that's like facing down, that's shading below. If the triangle that's facing up, that's what I was just saying. Like if it's the triangle, like see how all these lines are slashed like this? The one where it's all filled in underneath the line this way, that's going to shade below it. The one that's filled in above the line like that, this one, that's going to shade above it. Okay? So this is kind of like your less than symbol for the graphing calculator, and this is like your greater than symbol for the graphing calculator. Okay? So now if you know which way to shade with the inequality, like you don't necessarily need this, but if you're ever confused about where it's overlapping and that's hard to see for you, this might be a good way to go then. So you can just use the calculator to do it for you, to take a look. Okay? But that's the gist. Okay? So this stuff making sense to you guys, how we produce these graphs?
Yeah, I did it good.
Good. Okay, so Now, just so you know, these are all systems, right? We're looking for overlap and all of that. In your homework assignment, there are some where there's not even a system. There's just one instead of two equations there. Or just one inequality, rather. Those are even easier. I didn't even bother to do those because I figured you could probably do that. You type one in, check to see where it shades, draw the graph, done. That's all they're going to have you do is just do one of them instead of two. Okay? So I'm not even going to worry about that necessarily. If you can do these, you can definitely do those. Okay? All right. So one other thing we're going to do with these. So we're going to solve some inequalities in one variable. Yeah, man. This hasn't been that much yet. This isn't so bad, I promise. All right, so inequalities in one variable. We're going to be sticking with quadratic inequalities because that's been kind of the theme here. Except now it's going to be just with x, not with both x and y. The nice thing about this is your answer is not going to be a graph anymore, so you don't have to draw graphs for these. But we can still use the graphing calculator to help us get an answer. Okay? Okay, so we're going to take a look at this one first. X squared minus 3x minus 4 less than 0. Okay? Now, you don't have to do this every time. Like I said, you don't need to draw graphs all the time. I'm going to simply draw one just because I think it's helpful. Okay? But what I would like you to do first is graph this thing on your calculator. It's only one this time. X squared minus 3x minus 4, and take a look. And I'm going to, like I said, I'm going to draw a little sketch of it. But you don't have to do this. If you think that this is going to be helpful after you see me do this, that's fine. But it... Okay, so we want to know where is this parabola less than 0. Okay? So the first thing that we need to figure out before we can answer that question is, where is this parabola equal to 0? So take a look at the graph that you just produced. You can probably count and find them. What are the x-intercepts? -1 and +4. Okay, so what portion of this parabola is less than 0? Everything under the x-axis, right? If this thing is less than 0, those would be things underneath the x-axis. Okay, so I'm going to take a little highlighter here just so we're clear. It would be that, right? It doesn't matter for this. We'll discuss that in a minute, what we do with that, though. So that's the part of the parabola. So your answer for this, it's not x and y, it's just x. So what values of x produce the portion of the parabola that I just highlighted?
Greater than -1, less than or not -4.
All right, exactly. So it's all those numbers between -1 and 4, right? If I plug in any number in between -1 and 4, I'm going to get something negative as a result, right? Because that's the part that's underneath the x-axis. So my answer to this question is not a graph, but it's an interval. You guys know what I mean when I say interval? From here to here. It's not just one number. It's not just two numbers. It's a whole bunch of numbers, but it's between these two. Okay? It's between -1 and 4. So you have to write your answer as an interval. Well, how do you do that? Well, you've done this before, believe it or not. Looks like that. Should at least look a little familiar. It's called a compound inequality. But basically all that if you look at it, it makes sense. X is Bigger than -1, but at the same time less than 4.
Yep, I agree.
Okay, that's an interval. From -1 to 4, x is all the numbers in between. Okay? Now notice how I left these as less than symbols and I didn't put the or equal to parts underneath them. Why do you suppose that is?
Because it's 0, not less than 0.
Nope. Good guess though. Yeah.
Because in your first equation, it wasn't 4 equals 2. It was just...
Yeah, I don't want to know where this parabola is less than 0 and equal to it. I just want to know where is it less than. So -1 and 4, are those points less than 0? No, they're equal to 0, right? So I don't want to include those because I'm not concerned with where it's equal to 0. I'm just concerned with where it's less than 0. So I don't want to include those 2 points. So I don't put the or equal to parts on there because that would be telling me that I want to keep those. Okay?
If you're trying to find something that's less than 0, how can 4 be less than x? Or 4 be greater than x? I don't.
Okay. So what I'm saying that you're confusing you're confusing x and y again. So this is where the entire parabola comes out. The answer, if I were to plug an x in, the answer comes out less than 0. Okay, when I plug things in, the things I plug in are x. The things I get out are y, right?
Above -1,
Mm-hmm.
less than 4, that's my answer.
Yeah, all those x values, when you plug them in, you're going to get an answer that's less than 0.
Yeah.
It's not the shading thing again, though. I'm just looking for x values. So it's just the x values between -1 and 4. It's not all the little ordered pairs in that little space. It's just the ones along the line between -1 and 4. Okay, that's the difference between 2 variable versus 1 variable.
-0.99. Right?
No, well, whatever number you give me that you think is as close as you can get to -1, I can give you one closer. So my answer would always have to be no to your question.
0.9 repeating.
You can't use that because that's exactly equal to -1. Yes, it is. I'll prove it to you later. Okay. Anyway, I'm not crazy. I'll prove it to you later. Okay. So, any questions about that process, real quick? Okay. Let's. Not that question. A different question. Let's try another one. Levi? Did you have a question?
So, I don't really understand what the solution is, though. Like, what's it?
The solution is a set of x values. That's it. That's it. When we were doing the shading, the solution was a bunch of ordered pairs. They were points, x and y together. This solution is just a bunch of x's,
So
and that's it.
All the x's between -1 and 4,
Mm-hmm.
if you plug it in, it'd still be less than 0?
Right. That's all it's saying. Yep.
Is it always going to be a less than sign?
No. Depends on the problem. Oh, in here you mean? With these? These will always be less than signs to make that interval, yeah. But this might be something different. It could be greater than. Yeah, for this one. All right, so let's try one more. How about solve x squared plus 7x plus 12. And let's go greater than or equal to 0. And again, I'm going to draw a little sketch here to help me. So go ahead and graph that on your calculator. You might need to zoom in to get a good look at this one. If you think you know where they are, though, maybe it's not a big deal. But remember, the first thing you got to do is figure out where those x-intercepts are. So it should be -4 and -3, if you look closely at that. Okay, so this time, I want to know where that thing is greater than 0. Actually, greater than or equal to 0. So the parts that are greater than would be above the x-axis, right? This time? See how that's changed? The inequality symbol switched. It was less than, hence below. Now it is greater than, i.e. above. So if we highlight the parts of this parabola that are above, we actually get two chunks this time. There's this piece over here, and there's this piece over here. Okay, so how do I describe that? I'm going to actually have two different intervals here. Got an idea, Jason? Mm-hmm. So we want to go, and you don't even have to say -5 necessarily, because negative like 4.5 would work still too, right? So you don't need to necessarily jump to the next integer down from it, but anything less than -4 should work, right? But also greater than -3 would work, okay? So we're going to write just exactly that then, okay? If it's two little intervals like this, we would say, okay, x needs to be less than -4, or x could be greater than -3, right? Those are those two pieces. Less than -4, greater than -3. But you catching what I forgot to put on there?
I wrote it all like you did for the first one.
The line equals 2.
Oh, well, it's not the interval between -3 and -4, though. Because that would be this piece down here, and that's not this one.
But I wrote -4 is greater than x, and x is greater than -3, right?
You got to do it as two separate ones, though, because it's two separate intervals that we're looking at. It's not all one together. To write it that way, it'd have to be one interval altogether, okay? So, yeah, I forgot something. May you catch that? Alex?
So wait, just like to make things clear in my head.
Sure.
For the highlighting,
Uh-huh.
so, right? So highlight your,
I'm just doing that to help you see what you're looking at.
okay.
You don't necessarily have to do that when you do your homework. I think it'd be helpful, but it's not necessary.
So is it like the same thing where like instead of changing the thing, but like it's greater than above?
Yeah, you can think of it that way. Greater than above, less than below. Mm-hmm. So, Claypool, tell me again, what did I forget to put on here yet, though?
The line underneath the thingies.
Oh, yeah. So it needs to be those, right? Because I want to include the places where it's exactly equal to 0. And -3 and -4, that's where it is exactly equal, so I got to make sure that those are part of my solution.
I could say -3.99 repeating, and it'd be the same answer.
It would be.
According to Mr. Harris.
It would be. Yep, you're absolutely right.
I'm not right.
I'm still proving it to you later. I will. Anyway, so for this one, one thing that we talked about second hour was whether or not the inequality symbols in your answer have to include the little line at the bottom. Just make sure they match. I mean, you can think this through about, okay, this needs to be included, this doesn't need to be included. But the inequality symbol here and the type you have here should match. Okay? This one has the or equal to, so these need to have it too. Okay? Well, just make sure they're the same, and you're fine. Okay? So, all right. I'm going to have you do one more of these totally on your own. If things look good, then I got actually one more example, and then we're done. That's just two more now. We're getting close.
And then one more after that.
And then, like, I don't know, 6 more.
Actually, because 1.99999 is the same as 2.
Just do that.
I know the answer.
Do you?
I don't actually.
Okay, try it then.
Little brick.
Keep in mind with this one, it's less than, right? It's less than or equal to, so make sure that your answer is written the appropriate way.
Is that effective?
Yeah. Here's your answer.
Oh, I knew it.
So
Yeah.
the x-intercepts are 1 and 4. I want it to be less than or equal to, so we're going below the x-axis there. And it's this part of the parabola then. So it's that kind of answer, right? It's an interval from -1 to 4, or 1 to 4 rather, sorry. And I had to make sure that these were both included as well because it was there.
I had the same thing, but I wrote it 2 separate ways.
You wrote it 2 separate ways? Is that what you said?
2 separate chunks.
Like X is
Oh, yeah, if it's one interval like that, just write it like that as the one. Okay. Question?
Yeah, I don't understand why, like, the one before this had 2 things and this one had 1.
Okay, how many things do you see highlighted right there? You see 1. How many things do you see highlighted right here?
2.
alright.
There you go.
What won't you highlight, like, you put that highlighter, like, how do you know?
How do I know what to highlight?
Yeah, like,
I knew to highlight these 2 pieces because this one was greater than, and I had to highlight everything above the x-axis.
so greater than is 2 things.
Not necessarily. If the parabola opens down, it could be different. So highlight everything that is above or below depending on what kind of inequality symbol you have. And then if you have 2 chunks, you have 2 inequalities. If you have 1 chunk, it's 1.
So everything above it, right?
If it's a greater than, it's above. That's what makes it above.
Please excuse the interruption as our bullying awareness and surprise fact of the day is over the last 3 years, there's been an 87% increase in the number of child line counseling sessions about online bullying. Remember, what you post is out there forever, and online bullying is just as bad as a physical one. Please don't forget, the Powder Puff game is next week, Wednesday the 14th. Council is also hosting a card smash. There's $1 per hit or $5 for 6 hits. The craziest outfit gets free swings. Hopkins Robotics teams from the high school and middle school will be collecting new Lego sets for Dawson and other children at the Ellen DeVos Hospital. There's more information in the office. Powder Puff players, please be sure to check your email with information regarding the Powder Puff game. The last day to turn in information for Powder Puff will be on Monday. Football players, please be sure to check your email for information regarding yearbook and coaching Powder Puff. Monday will be pajama day to kick off homecoming week. Spirit Count will be taking place during third hour. Student Council will also be hosting a penny drive all week next week. This will be for spirit points as well as any money collected will be donated to Ellen DeVos Children's Hospital. Thank you.
Okay, last one, guys. All right, and then we're done. Yep. Mm-hmm.
For the, what you just highlighted, how does it equal, like, lower to the graph?
How does what equal what?
Yeah. Less than or equal to.
Uh-huh. How does the equal to relate to the graph? I'm including these 2 points. So So I want to know what portion of the graph is less than 0 but also equal to 0. Well, these 2 points, 1 and 4, are equal to 0. So I got to include those in my answer because that's actually part of that still. Okay. All right, type in this one real quick. I needed to show you one more here before we're done, guys, because all of the examples that I've given you so far are ones where the intercepts have worked out really nice. Where you graph the thing and you're like, oh, that's a 3 or that's a 4. I can tell that. Well, this one's going to be not so nice, okay? And we need to be able to pick out where those are still. Yes?
We're going to have to graph it and then
Uh-huh.
left bound, right bound thing.
Right, we've done this before.
Like
Okay, but I'm going to...
zero thing, whatever you're talking about.
Uh-huh. So, let's do it. Okay, so here's the parabola. Okay, this one happens to open down as well, which is new. They can do that too. All right, so those x-intercepts, little refresh for you. So second, calc, 0. Okay, so you're going to hit second, and then it's the trace button, actually. And it takes you into this calculate menu, and you want to go to number 2, 0. And so when we're here, this is where we got this little spidery guy running around here. Okay, that's our little cursor, and we need to go to the left and to the right of where we think the zeros are. So a little bit to the left, I'm doing the left 0 first. So a little to the left of where we think that is, hit enter, and then move it a little to the right of where we think that is, hit enter, and enter one more time, and it should pinpoint where that 0 is. So the first one... Yes, it should. That's part of the graph, actually. So what we have here is, if we're going to draw a sketch of this thing real quick, we've got a parabola opening down like this. This particular 0 right here we just found, that was negative 0. We'll say 69. I'll just round that off. Now we got to go and find this one. Same process. Second, trace, number 2. And then we're going to move over to that one. And go a little bit to the left of it, which would be about right there. And then a little to the right of it, which would be about right there. And then enter one more time. And that 0 is at about 2.2. Okay. So, now that we know where those are, this process is pretty much the same. We just got to use those numbers. And I want greater than or equal to 0. So which part of this parabola am I going to highlight? Everything that's above, the top little part of it. Yep. So it's going to be this. So it's going to be another interval kind of like the one we just did. Okay, except it's from negative 0.69 to 2.2. So negative 0.69 less than or equal to x less than or equal to 2.2. Okay, does that make sense? The fact that they're both going the same direction on there? Yeah, I know. Okay, so I'm going to get your homework assignment up.